pleasure for me to be here and to give you a little bit of insights into what I do as a professor at university on like simulation and working with. So the title you see here is called Bridging the Gap Between Academic Software and Industry Needs, and I'd like to tell you about some of the ways like we as a research group interact with industry. So there was this mention about like the gap, and you see this quite often here, and so it's also good as an academic to know that there's a gap if you want to board a train, and you see these trains are very fast sometimes, so is industry, and so we have to be there, and maybe with the right balance we can still hop on a train and provide some very useful tools to like industry materials development in our case. So this is the outline of my talk. I first will start and give you a little bit about my personal background and what our software does and what we do in materials modeling. And then I'd like to talk a little bit about what is my experience on like what industry needs and how I see the academic reality, and this is sometimes comes together and sometimes does not come together. And then during the history of my academic career, I had different forms of like working together with industry. You can also call it business models. And then finally, I received from Alex comments from all of you, and I'd like to address some of the points where I can give you just my personal view on it. So I've worked at many different places during my academic career. From my training, I'm a physicist and with a specialty on computational physics, and I did my PhD on the Donau University of Technology. I was with IBM at the Elmerton Research Center. I was professor at Sheffield University, and then I moved back to Austria, and now I'm with Donau University Krems. So, but in all the stations of my career, I did more or less like software development and applying the software for mostly magnetic material design. And I'd like to give you an example. So what you see here is like, if you open a computer and a hard disk, like in former days, nowadays there might be SSDs, but hard disks are very, very important still, like in data centers, not so much like in the devices we carry around. But what we did like at university still, and also with like a spin-off company, was software for magnetic storage. And I'd like to show you one example, which is like some research we did together with Seagate Technology some while ago. So one way to put more data on a hard disk is to do heat-assisted magnetic recording. So what you do is like you don't only have like a write head which creates a magnetic field to switch your tiny little grains here, like your particles, which either are up and down and code like the information. Because these particles are so small, it's so hard to switch them with a magnetic field. So what you do, you provide more energy with a tiny laser spot, and with this laser spot and magnetic field, we can put the data onto the hard disk. And what you will see here is like hopefully a simulation of like how this laser spot flies over the hard disk, and we see that like here there will be a bit pattern which will be developed, and on the top we basically have a cross section of the material. So let's see if this works. Yeah, so here comes the laser spots, and that's also an alternating field, and so we put some information onto the hard disk. So then we have to post-process this, because this alone just shows, okay, we're able to write data on the disk. And what we do is we calculate many tracks, and with these many tracks, we can do some statistics, and from the statistics we get some signal-to-noise ratio, we got some bit transition width, and these are all the parameters the hard disk companies need, like to engineer their material or to engineer the write head or to engineer read head. And with our software, we basically provide some tools to help them in decision making. So what comes now is like some very personal view on how to work with industry. So this is my experience, and I know like your experience might be different, but still maybe there's some value from what I tell you now. So the first thing I noticed when we work as academics, we are more or less research driven. So we want to write research papers, and we are interested like in very scientific type of questions. On the other hand, if you go to industry, they are product driven. So the next product release cycle is in maybe 12 months or 18 months, and then many design questions have to be answered. And this is what I immediately learned when I interacted with hard drive companies. So there is this product release cycle, and so everything has to work in favor of releasing these new products, and there are many design questions which are addressed with like computations, and so you have to make your computations in a way that you give the answer in the right time. So this is very different from academic research, where you write a paper and you focus on many scientific questions. So time to solution is like mostly everything like in the industry world. And this time to solution has like many flavors. So first, you have to focus on the very relevant problems. If you use software, you want to have a manual where for every example you have, for every problem you have, you should be able to look it up in the manual so that you can to continue your work. If you provide as an academic software to industry, it doesn't work without a demonstration version, so it was like my experience. And it's also very important that they have a hotline where they can call you or send an email anytime during the year. So this is very important to have support. Also, what is very important is that like the need changes over time. So within a few weeks time or a few months time, suddenly there's another topic relevant in industry, and they want to have like still use your software, but you have to customize it to the new problem, to the new question. Confidentiality is a very important thing, so you have to make sure that your business partners trust you, so that they give you some confidential information, and they have to be really sure that you keep it for yourself, because they know that you also work like with another company that is a competitor on the market. So they really have to trust you as like a company, as a person. And what's also very important, I realized, is that companies want to have long-term guarantees, so that most of the time they want to have permanent licenses, and they want to make sure that they can use the software like over many years. On the other hand, like we all know how it works in academia, and we had a few of these topics like during today and yesterday's discussion. So it takes time to make a good software. Most of the time, there is no real documentation. There is maybe a PhD thesis, there are a lot of papers, but a detailed documentation of why like this one line of code looks like this, or how this all comes together, this is, I think it becomes better and better because students are more trained also in computer science, but still it's not at the level we want to have it. One of the main issues I realized is that the workflow is very different. So at universities, we want to solve the scientific questions. We have time to do post-processing of the data. The way we visualize the data, the way we look at data is very, very different from what is done in a company. The input data is also very different because at the company it comes from another simulation process, it comes from experiments. So I guess that academics, we are not really used to an industry workflow also concerning data. At university, we have many developers, so the code grows over 20 or more years. So, and like different groups of people, different students, different postdocs work on it. And yeah, there's no continuity, there are gaps, there are other people starting on it, taking it up. So this is the problems we all know ourselves. What I'd like to show you now is like 4 different models on how I interacted with like industry. So 4 type of business models. So the first one is like private consultancy, where like I as university professor do consultancy for like companies. There can be university projects directly funded, collaborations with industry who sponsor some research, and in return it could be just joint research, and there is no like real software transfer. So it's software still is at university, but there can be also university project where part of the agreement is that the software can also be used at the company side. And then what turned out is also a very good business model is like what we did was we started a spin-off company, and basically we sell software and we also provide some services. And I'd like to go a little bit into more detail now and show you the pros and cons and my experience with these different models. So when I was at the University of Sheffield, there was this very nice scheme that basically the university encouraged us to do private consultancy for like a certain period of time during the year with support from university lawyers and university contracts, but we were really encouraged to go out in the business world and do consultancy. So this was very interesting because I could really address some industry questions. So sometimes these were situations where we really could make impact on like a product or product design. So this was really rewarding. And with some companies led to joint scientific publications. So this was really good work. One negative side on it, this is a time issue. If you work with a company, yeah, there's a certain amount of time pressure. So when you submit a journal, normally a paper to a journal, nobody cares when you do it. If you work with a company, so there is a certain time schedule they expect from you, and if you're fully academic, so this is like you have to find the balance. Another possibility was, and you've seen the background picture. So the background picture here is like, you know, it's the Golden Gate Bridge. So, yeah, very different. So what happened is that I realized that these different business models work like in different regions of the world differently. So with companies in the United States, like in the Silicon Valley area, like this private consultancy was one of the common routes together. With companies in Asia, like Korea and Japan, they like to do like really funding the university, and by funding the university, they either have access to our software or we just do a joint research project. Which like is also nice because it gives a lot of money for your research group. You can fund a postdoc. You can have time and money to adjust the software to the specific industry needs. There's not so much like papers coming out of it. One side, and we talked about it also yesterday, the university is really involved, companies are involved, both have the lawyers, and it takes some time to get an agreement. And sometimes, it depends on the companies, sometimes you provide a lot of input, like with your research, but you don't really know what the company is doing with it. So that's sometimes disappointing, but it's not always the case, and there is also very open collaborations. And then finally, like I guess 2007, we started also our spin-off company. And this was more or less happening by chance. So in the end, or in the beginning, the idea was, okay, I'm at university, and whenever somebody from outside wants to use our software, so why don't do a university project? But what we realized is for some customers, it is much easier to work with another company than to work with university. And so basically, some of our later customers approached us, hey, if we can buy your software from a company, then we will immediately use it. So that's how we started basically our company for like magnetic simulation in this hard disk business. It has some advantages. Also as a company, we can respond very quickly to like industry needs and questions from our customers. Concerning confidentiality, that companies trust me as a person, come as a company than when I come as a university, so that's, I don't know why, but it was easier for me to interact with customers like as a member of a company than as a member of the university. It brings money for code development. If you are a company, you can then hire like students, you can give money to postdocs to develop specific functions in the code. There is basically no joint research like in us as a company and other like users of our software. Of course, there are some negative sides or some things we have to think of. The one is sure that we have the necessary time for support, and we spoke about contract, so this is something we learned, so it's good to have a lawyer to take care of all the contract and licensing situations, and we were a little bit naive on walking into that, but we learned it immediately that this is something, and we learned it in time, so there was no problem, but it's good to think about it whenever you sell something, to have all the legal framework and also the knowledge background in your company. So what gaps can we fill with this company? So the first thing is, I think it's starting the spin-off was helpful to really address the industry questions, because there are no research obligations. We can do what the company wants. We can customize the software to the industry needs, like in time, whenever there is some new questions from the industry, we can react and quickly have new functions in our software. And already talked about confidentiality. It seems to work better between companies and companies. So in the end, like as a spin-off company, we have different forms like of income. And so this is just a list on like how we start to interact with a company and what ends up. So we found that companies want to have demonstration licenses. And the best way we found is that it's good, and if you can convince the companies, don't give a demonstration license for free, but charge for the use of the demo license for a limited amount of time, but also like then give the support which is needed so that the customer can really use the software and knows how to apply the software for the business needs. And if you do so without charging for a demo license, you have to do a lot of work which you have no income for it. And we realized that this really works, and if the customer pays for it, also use the demo software because they paid for it, and then it was a good idea to do so. Then we sell our software. Mostly it's permanent licenses, but we also have this system that it's a modular software, and whatever package the customer wants to have, we adjust certain combination of features for them. We do training courses, and so we go to the customer and provide like a 2-day on-site instruction to use the software. We have a maintenance agreement for updates and technical support, and then also we have some agreement on customization. So if there are new feature requests, so there's a specific way, so how we can provide the new features and how we can also charge for new features. And so basically the last two parts, like maintenance and customization, is what's like is important for us to have some income, because there are not so much companies in the world who do magnetic recording or who make permanent magnets. So this is like a limited number of customers. So now I come to some of your comments in the questionnaire before the meeting. So there was one, how to build more awareness of your software. And my experience was, it's twofold. It's good if there is an open source project which is very related to what you do. Maybe it also comes from your group, but it shows like that you can solve these things. And then the other very important point, I guess, is that if we know as academics really the state of the art in a certain field, and we do our research based really on the state of the art, and we talk about it at conferences and in our papers, like the industry will see it and will approach you. So this was my experience. We don't have a sales department. Like people come to us from, like you've seen, from different continents, and they approach us and say, okay, you can really address some of our problems. But the important thing is, and this is something I realized especially in magnetic recording. So there are many ideas from academics on how to store data, but you have to be aware that what the current technology, and the current technology in data storage is like maybe, say, 12 times 23 nanometer is 1 bit, and so it's important to know what's really the state of the art and to show it in your own scientific research, so that you have awareness and the companies know that you can address their problems. So what really helped is that during research, like one of my PhD students, like basically developed a very good software package which more or less does similar things than our commercial package, but maybe with a different focus, but it is open source, it has a good visibility, it's cited in many scientific papers, and so sometimes companies see it and say, can we use it? And we say, okay, you can do this, you can of course use it, but there's also some kind of commercial branches of the software, and for specific needs now, we have like 3 different commercial software packages, one focused on magnetic recording, the other one on spin electronic devices, and the third one on permanent magnets. And so this parallel stream of having like an open source product, which is mainly used by universities, and like some kind of similar and more focused commercial products. So this was very helpful.
So these are four different companies?
No, it's basically an open source project. There's one company, and these are different software packages for different purposes. Yeah, within the one company. Yeah. Yeah. So another question was like in this questionnaire, when is the software industry ready? And so this is just like my experience here. So I think the user interface is not so much important. I think the most important thing, can it answer like an immediate current industry design questions? So can we help development process which is currently important in industry? Of course, like documentation and a manual, I think this is a key point. It should be ready to be used in the industry's workflow. So also on the next slide, what I mean with it. So it should be easy to use, and the company should be able to use it immediately. And so that's not necessarily a graphical user interface. So how did we manage this? So many companies used like finite element Maxwell solvers for the design of the write head recording magnetic data storage. And so if they had a workflow from like finite element modeling to some analysis of like the potential on how to put data onto the hard disk. And so what we did, we basically provided interfaces to their own data format they had already with finite element tools. So they had already formats, and so what we do basically read the same data format. Then there is no graphical user interface, there's just like kind of a parameter file which tells the software what to do. But then on the output level, it's the same as in the input level. We provide data formats that can be used again in the company's analysis tools. Or as well as, like PartVI was mentioned today already, like in some of the public domain visualization and analysis tools. And we also help the customers to adjust like this post-processing tool according to the needs. But with this we avoided to make like this graphical user interfaces, and for the customers it was like easy because they could use the same workflow they were used to like previously. So maybe a few words to this like ease of use. So you told us yesterday, so maybe it was like low on the priority list because more or less everybody assumes that whatever we sell, it should be easy to use. And what we found is really important, provide a lot of examples which like link to what we want to do. Training, a very important point, so a training course and like really tell your customers like how to use this, how to address the important part is important. It also helps a little bit to give your customers some feeling on the physics behind and on what's really going on in your simulations. So it's a little bit teach the basics first in the training course. So it's good to also provide the necessary physics background to some extent. And then I think this is also very important, provide help for data pre- and post-processing so that like what we have is integrated in the company's workflow. And there's always this cloud-based solution, which of course would be very easy, would be very helpful, but what we found basically with all our companies that work now, there's a security concern and industry wants to keep the designs in-house, they want to keep the key material properties in-house. So there is no way to exchange data other than sometimes really on a hard drive or sometimes very encrypted by email, or when something comes by email, it's not necessarily, it's a surrogate model of what's really happened. So security is a big concern. And there was one question on how to install the software at the customer side. That's my experience on what we do. So recently we use a lot and do a lot with Docker containers. What we also do, and it's also very full, and we compile and link for the PartVI platform the company has. So we ask them specifically, what is your hardware on software configuration? We build a virtual machine with the very same configuration, and we compile and link the software, and then what we ship is basically a linked executable of the software. It's also because it's very stable licensing mechanisms. If they change the hardware or the software, we immediately know that it doesn't work anymore. So this is a very side effect. And yeah, it also works. Some of our customers, some use Windows or Linux, so with MinGW or SACWin, so we can use this method of compiling and linking for the PartVI platform, also independent of like the operating system. So this comes to the summary. So the lesson I learned, like to bridge this gap, is like respond quickly to industry requests. Concerning the business model, I realized it's good to be flexible and being still in an academic position, I can do so, and on a case-by-case basis, I can either do consultancy, I can have an industry-sponsored university project, or we sell the software like from a spin-off company. And what's important for the spin-off company is that services after software, like it's good to have income, and it keeps a long-term like customer relationship. Thank you.
Thank you very much.